Hello, everyone. So this is our September 2018 SIM meeting, and we have a bunch of things to discuss today. We are going to go through some of the proposals that we discussed in the last meeting. So those are some of the proposals in the first batch that we put to get some feedback from the community. So we discussed that batch in detail in our last meeting, but we want to go through it again and see what actionable things we can do so that we can move them forward, and also pinpoint exactly which proposals are blocked on other things, technical things that need to happen in the future. After that, we are going to introduce batch 2. So batch 2 is championed by Martin. And that batch essentially contains 4 proposals. 4 new proposals plus an old one. So the 4 new proposals are 4 new additions to the type system that just have to do with union types, intersection types, implicit function types, and dependent function types. And the old proposal is related to our trait parameters proposal that we had for the Scala 2. That proposal was dormant because there was no one that would implement it. So we're going to pick it up again, and we're going to put it in an active state so that we can start thinking about when we are going to implement this feature, so that we can unblock some things we have in the pipeline as well, and so that we can shed more light on the Scala 2 Scala 3 migration process. Good. So that being said, let's just dive into the proposals that we have for discussion. There is not a lot of things to discuss about auto application because we need to still be more precise about the compatibility with the Scala 3, and we need to create like a better motivation and also merge it with the expansion proposal, or see how like these two could be together. With regards to XML literals, we have some things to discuss. Particularly, there is some updates. Someone here at the lab, Alan Renuzzi, is working, like in the Dotty team, is working on a JSX XML interpolator. So maybe Martin can fill us in about that. And Seb is the champion of this proposal, so he's just gonna like re-summarize and just raise new points of discussion that we maybe have to look at again. XML, yeah.
Not much has changed since the last time. One thing that is progressing is that so Adam, you mentioned it, has been working on an implementation for Dotty of something that would go into the direction of XML interpolator. Right now, it's focusing on JSX subset, which is arguably what's important for many people. And yeah, other than that, it's still a big debate. I do have one possible way to go a bit forward, both on this proposal and on the procedure syntax proposal, which is maybe we shouldn't spend too much time focusing on them right now, simply because when we break them, when we do remove those things, it's going to be a source breaking change, but not a binary breaking change nor a tasty breaking change. It's not something that, if we keep the feature now, we need to bake the semantics of that feature inside our tasty and binary formats. So maybe we can just let them be, and because we could remove them later. Like if you remove them in 3.1 and 3.2, it's not going to be harder then than now. And maybe we should focus on the things that have an impact on the tasty format and or the binary format.
Yeah, I think that's a really good point.
All right, I support that.
Maybe we can put it behind a language flag, so you'd have to do import language XML literals.
What would be the positive effect of that change? So to me, it looks like additional imports for basically nothing, right?
Well, because if the plan is to eventually get rid of something, then we want to notify, we notify people of that in release notes and so forth. But I think, that one of the things that we do with features that are on the way out are attach some sort of warnings to them, whether it's a deprecation warning or whether it's requiring a language import, as we did for postfix ops. So it's it's about making sure that people know that they're using something that's on its way out.
However, to decide that these features are on their way out, we need to vote for that, right? Like it was with the CP18, for instance, a while ago. So if we decide to postpone this vote, then maybe we could just hold on introducing that import.
But the feature syntax is already deprecated, if I understand correctly, right?
Yes, I think so.
Technically, yeah. But we had still the opportunity to remove it before it goes to RC. No?
It's future deprecated.
I think on 2.13 it's not actually deprecated, but on 2.12 it was deprecated in the future.
Okay.
So I remember
in M5 it's not deprecated?
No, 2.13 it's not deprecated.
Okay.
Without condition, I think.
So you said something that I believe deserves a bit of clarification. So in Scala 2, if I'm not mistaken, micro release, or I guess that's called minor release, is binary compatible. So 2.11.12 is compatible with 2.11.11 and so on. But a major release is source compatible and binary incompatible. Will that change in Scala 3? Because it seems to me what you suggested was that 3.1 and 3.2, they can break source codes between releases.
Well, I mean, major releases have never been really source compatible. That's just not true. Every time you change anything in your API, you add a method, you can break source compatibility for someone. We even notice that every now and then when Java adds a method. So
sure. No, I'm well aware of the difficulty of guaranteeing source compatibility. But however, the message has been that upgrades are very easy when we do these kind of major releases, and there's a community build which ensures that projects still build. So even though, let's say, to be 100% source compatibility, it's almost impossible. The 2 series has done a remarkably good job and set a standard where you imagine that upgrading from 2.11 to 2.12 and to 12.13 would be relatively easy, or you won't have to do any source code changes in your project, or very, very little. So I think that's now breaking that, saying XML literals can go away on one of these releases probably deserves some warning, or to me, this would be a huge surprise. I don't know if I'm the only one who would be surprised by that.
In the 2x era, things can go away after, even in source compatible ways, after some significant period of deprecation. Right?
I'm sorry, can you maybe go closer to the microphone, because I don't hear you.
So if already in 2x, if something is deprecated, for example, method names, methods for some time, at some point we do remove them in a major version. So similarly, we wouldn't just remove a language feature without having deprecated it for 1 or 2 minor, then, well, whatever it's called, the second number. The 3.2, that one.
Yeah, let's call it major. I think that's how it's called now.
And move it in 3.3 or 3.4, depending on what promises we make. But something that is, I don't think the story for source compatibility is going to change between the 2 and the 3 eras. However, we are expecting the binary story to improve in the 3 era. And given that, we should focus on the things that will have an impact on this binary or tasty format.
So are we going to prioritize binary compatibility then? Like,
I think it's more like tasty compatibility, which is
right. What I'm suggesting is do we think going forward it's more important to ensure binary compatibility as often as possible and allow source to diverge, right? So you can compile against an old library that still uses that old compiler with a new version of Scala. Is that like a direction that we're moving as a community?
Definitely. You watch my year talk, but not everyone is.
I actually can't understand anything you're saying. I'm sorry. Can you say that again in the microphone? I'm sorry.
It's literally
It's probably a
possible,
connection
but,
issue because
yeah, I was like,
it's probably a connection
okay.
issue.
So what I said is, personally, if you ask me, definitely, I strongly believe this is our best chance to improve significantly our compat story in general. My Scalasphere talk is very adamant about that, but not everyone agrees with my opinion on the matter. Some people strongly believe in source dependencies, for example, and we should rethink the whole thing to base everything on source dependencies. Fiori is basically a tool that goes into that direction.
Yeah, I don't think you're ever going to get everyone to agree. But the decisions that you make here on the language impact which tools will work best, right? So if we make decisions here that say we're going to prefer remaining binary compatible over source compatible, right? Then inherently those decisions actually impact the rest of the community. In the past, it was we're going to retain source compatibility, right? And so a lot of the tools are designed around that and around that notion. And so our ecosystem has built up this whole notion of like source compatibility is the way to go. If you look at the tooling space and where it's moving, I think it's moving that direction, right? So if we're gonna, the Java ecosystem was like the opposite. It was all binary compatibility, right? So we were this oddball. The question is, like, should we try to unify that, or has the Scala community kind of like moved past some of its Java inheritance and like we have a good source compatibility story now? With things like Fiori coming out, right? I don't know. It seems like to me from a tool space, even external to the Scala community, people are moving towards source compatibility and source-based builds. That seems to be the story that everyone else is moving to. I think you're right with Tasty that we have the opportunity to make the binary compatibility story awesome, but I don't think we want to make that decision very lightly, right? Anyway, I don't disagree with you. I actually think it's a good opportunity. Binary compatibility gives us a lot of wins. I don't think we're ever going to get anyone to agree, but we should have a notion in this committee how we think the language should move forward, right?
This will be hashed out in November. Is that something that we should set aside for?
Yeah, sure. But I mean, I think it's an important point that we have to discuss because
Okay.
it will also like set us up for many of the discussions that are to come. So just regarding your point, Josh, I don't think that source compatibility, breaking source compatibility would difficult so much the maintaining the source-based builds like Bazel and Pans, because anyway you have like a set version for a set Scala version for the whole build, right? So at the moment you migrate everything, and you usually do it with rewrites that are easier to work on the source level than the binary level, right?
Yeah. I'm not saying so. The way that we make this change can be friendly with source. Like even if it's a source breaking change, we can make it friendly with these builds that build everything from source. Like it's just again, it's a decision I think we need to make and make sure the tooling stays in line. Mostly, I think my voice here will be around tools as a surprise to everyone. But anyway, like that's as we make these decisions, like just saying we're going to prefer binary compatibility, if the tooling community is not behind that, I think it would be a mistake to move that direction without getting that support. That's my main point.
Yeah. Yeah, I agree.
Me too.
Yeah, from my perspective, I think that we sure we'll have to deprecate, but I definitely think we should deprecate XML for 3.0 at the latest. If we can do it for 2.14, so much better. But I think for 2.14 we won't have an alternative, but for 3.0 we will have it. Compared to XML, I think procedural syntax is completely irrelevant. I don't care one way or the other, really, but I care deeply about XML because the point is, I would like to be able to make the argument that Scala is a simpler alternative to many of its competitors like C# or Kotlin or Swift. If you look at the languages, then they are all more complicated than Scala. They have many more features, they have many more rules, and so on. But as long as we have XML, that argument is dead in the water. There's just no way we can make this argument. So I think for that reason alone, it's really important that we get rid of it.
Mm-hmm. Yeah. I think that there is this other proposal that was just asking for some hooks and in the parser to implement.
As long as the Scala spec contains an XML parser, this argument holds. So.
Mm-hmm. Okay. Yeah, this is something that we definitely need to look into afterwards offline.
Yeah.
Okay, so let's move then on to the next discussion. So we have to discuss as well procedure syntax, and Josh is here to.
Mm-hmm.
Josh is the champion of this proposal. So this is a proposal that a lot of people, as many of our viewers probably know, and we need to make up our minds of it. It's clear that the last things to discuss in the meeting were that we had to give a better motivation, that we had to discuss why it's safer. We had to remove some of the examples that were misleading from the proposal and were, I mean, some people got confused by them. And then we also had to link to the Scala physics rewrite. At some point we discussed about that. So I mean, until we don't do these actionable items, we cannot vote on it. But I think it's interesting just to be clear on what committee would vote with regards to this proposal as it is right now. So I'd like to know mostly if there are any dissenting voices with regards to deprecating procedure syntax and then removing it on Scala 3. So dissenting voices are welcome.
Right, and to address people's concerns, besides the obvious, like, you know, I don't want to put another equals here because I think it's confusing and like visually distinct procedures from non-procedures, like that mentality, which I think is the main thing we should be debating, is like, are procedures really a different thing than a method that you want to have visually distinctive? That's like the big point. Besides that, I think it was all nuances. So the little fiddly bits of like, let's make sure this is well motivated. Let's explicitly call out what the tool is that does the migration, and let's clarify that we're not recommending people just say def method equals open bracket, right? Like we want people to explicitly write the unit, right? I assume. I think if with those fiddly clarifications, right? Like let's evaluate the proposal in terms of that, assuming the fiddly bits are taken care of, versus like this notion of I want procedure syntax to be a distinct thing that is different than method syntax. Because I think that's really the, if you isolate the debate, those were the only two big pieces.
Another proposal we need to discuss as well is early initializers. So this proposal was championed by Adrian. And what we discussed, so essentially early initializers are blocked right now in JParametric. We kind of all agreed on merging JParameters and having them in the language before we act on it. Because we don't want to confuse people. We just want to give them one concrete way of migrating their code from their early initializers to JParameters. So that's why That's why I've added trade parameters to the new the new batch that Martin is going to discuss afterwards. But I'm just explaining this in case somebody wants to raise any kind of opinion or concern with regards to early initializers now, before we move on to the batch, the second batch, and we discuss the new features that SCA3 will give us in terms of types. So it looks like we have no more feedback. So we move to the second batch. So Martin, can you tell us a little bit about the features that are gonna make it into SCA3 with regards to new additions to the type checker and new ways people can have better type safety in the programs?
Yeah. So what we're gonna discuss is intersection types first. So they're all in the Fluffy reference under new types. So intersection types are essentially a more respectable alternative of compound types, A with B. The difference is that intersection types have actually nice algebraic properties. So in particular, A and B is the same as B and A. So they commute. And the other thing is that they have been studied formally. So intersection types are one of the very few features that have been modeled in dot. So the dot theory rests on intersection types. Since people like to, undoubtedly like to discuss syntax, so I think the point to clarify as well, why don't we just keep with instead of and? For now, let's just change the meaning to mean intersection types. So I think that's confusing because if we inherit, so if class C inherits A with B, then that's definitely not commutative. So that's still linearization, and essentially if A and B declare the same member, then the B member will essentially override the A member, but not vice versa. So I thought that it would be very confusing to have essentially the same combinator mean something which is either commutative or not commutative. So they're two different things, and in the compiler there's actually a proof obligation then that they mean the same thing. So that means we have a class and it inherits A with B in some order, then it essentially has to be shown by the compiler that the class is actually essentially can be seen as a subtype of A and B. That's something that the compiler checks in addition to what happens now. So A with B, in short, says, well, essentially, we give an order to in what sequence definitions are considered and how in what direction supercalls flow. And A and B is essentially the true intersection, the set-like intersection, and there's a connection in the compiler between the two that checks that essentially A with B for users is the same as A and B. So that's the story for intersection. Any questions on that one?
Yes.
Yes, you have one. Yeah.
I think that would also be linked to union types, since they're two sides of the same coin, essentially. So this then basically for all new features, kind of interactions with existing features can we expect? Did you find problematic while developing DADI?
Right. So intersections and unions are really duals. And they behave like you think they would in that sense. So I wanted to do union types next. So union types is essentially, like I said, the dual of intersection. It's set-based union. There are several reasons to introduce union types. The most direct one for me is that well, we have already least upper bounds in the compiler. Like if you have an if then else, or you inference of type variables, then you have this problem that you have to say that essentially you need to find a solution for a type variable such that it's a supertype of A and it's a supertype of B. So in Scala 2, we didn't have union types, so you couldn't just say the type variable is a supertype of A or B and we instantiate it to A or B, A union B. So that meant we had to essentially do this very roundabout way to compute the LUBs, and that meant we had this problem of the exploding LUBs, because essentially without union types, these things can get infinite or very, very large, either infinite or very, very large. And it has been really difficult to tame that. So union types solve this thing, and that's essentially the main reason why we want to have them. Union types are also nice for modeling. I think in the JavaScript world, they're sort of everywhere. So union types is sort of very common there. Another potential use case is null safety, that we would have types that essentially the type like string would not be just be string without null, and if you want string and null, then you write string union null. So union types, the current implementation of union types is very, very conservative in the sense that it gets rid of these unions fairly quickly. We are still looking of whether we can improve that. Basically, make union types stickier than they are right now, but it's not an easy problem.
You're talking about inference.
For the inference, yeah, that's right.
Very clear for us, but maybe not.
Yeah, that's right. Yeah, so that's essentially union types. So there are several things where union types where we could be more precise at the expense of essentially probably more slower compile times and potential exponential explosion in compile times. That's always the problem that we're facing there. So one is that if you have a value of a union type A or B, and you want to select a member, and you could say, okay, if that member exists in A and it exists in B, then essentially just let the selection to go through and make the type a union type of the two types that you found. We don't do that right now. So what we do is we say, well, we need to essentially find the common superclass of these things, and the member must be in there. So for technical reasons, that helps. Essentially, lets us also generate simpler code for doing that. There are several trade-offs with union types. So I would say the current one we have is sort of on the inference side, the most conservative possible. So essentially, union types are the most ephemeral possible. We need them to get rid of these exploding LUBs, and we have them. If you explicitly declare them, then we will honor that, but otherwise they will go away very quickly. And we might tune that further, but I think it's probably good to start conservative, because then we know basically our current solution is the one where we know we have the least possible problems of type inference, type checking, compile times, at the price of potential loss of expressiveness. We might become more expressive in the future if that's possible. Okay, so that was union types. Any other questions on union types?
Maybe a quick one in terms of contrasting with existing or maybe potential confusion around other people's conception of what union types are. So you mentioned their set semantics. Other languages, they're tagged, for example. So I don't know what the mental model is going to be from an existing Scala user, but people coming from other languages. I'm concerned maybe like the modeling aspect of it will be, say, overused. I don't know what your current experience is with that, having played around with union types for a while now. It's just an open question for me.
Yeah, sure. So there is so one thing I forgot to mention before, another use case is actually extremely performance critical code. So, because these union types, they're untagged unions. So if you have, let's say, a union of string or integer, then you don't have a left or right tag or anything like that. But of course, you can figure out what it is by doing a type test, whether it's a string or an integer or a type pattern match to do that. And that, as you can imagine, is more efficient than using an either, because it doesn't use the boxing tagging, which might tempt people to overuse it. Yes. So I would say for extremely performance critical code, I would do it, but otherwise we have a danger of overuse. There again, less expressive union types are probably less dangerous. been overused, more expressive.
Well, I can provide some experience about that, because as you all know by now, Scala.js already has union types in Scala 2, and they're very limited. They were put in Scala.js for the modeling aspect because we desperately needed them to represent some JavaScript libraries. Like, there was no way around it. But then I noticed that some users managed to already overuse that one. I think there's, I mean, I've seen people manipulate unions with 5 or 6 different types of variables, and there are big unions everywhere, and for no interrupt reasons, just because they like to do that. Instead of using a CL to CL trade with case classes or something. Nevertheless, I don't think this should stop us, other than document things, say when things are appropriate, when they're not, because it's not like, I mean, in Scala, everything gets overused anyway, right? So it's not really, every feature that we put in Scala is going to get overused. So I'm not sure discussing whether unions are good or not, depending on whether we think they're going to be overused, is constructive.
The solution to that is make all your features boring, and then no one wants to use them. But anyway, I actually have a real question instead of just peanut gallery comments. So regarding boxing, you mentioned that if you had a string or int, that it would not box. So I assume you mean the string won't be boxed, but the integer would still be boxed?
Or integer, I meant the Java.
Right. Yeah, in Java. So what is the story then around like auto boxing, or I know that what's it called? The stuff that Julian worked on that lets you get rid of boxing. I
guess.
Yeah, that's going away, right? Like we don't have to worry about the interaction of that feature with this feature in Scala 3.
That's a very good question.
Guys, can I? It's not. Sound quality is actually completely independent of the position of your microphone. So maybe you could quickly check if Hangouts is actually using your mic.
Okay.
I hear you a lot better, and I think you're closer to the laptop.
Okay, I took it out now. The mic is out. So this.
Yeah, I can hear you very well.
Okay, this is just the laptop. Okay, now I'm going to put back the mic. If I get.
Yeah.
How do you hear us now?
I would say the same. I don't know if anyone else has a different experience.
It seems to be network latency. If any of the rest of us are talking and then Lausanne tries to talk, we lose sound.
Okay. Is this better? First, yeah, don't do. That's the thing. Also with.
I think you can do it. I don't hear anything.
Do you hear? You don't hear anything?
I hear you, but if you tap the mic, it's fine.
Yeah,
I think it's the laptop.
Don't type the mic.
Okay, why
it's
not?
not good for the mic.
Okay. Well, I don't know then.
And if you just check the settings in the Hangout at the top of the window.
That's what we're looking at. It's selected. So
Yeah.
it's like explicitly selected.
Definitely the AT.
Okay. Well, all right then.
Don't do
Maybe
it.
we'll
Go on then.
microphone next time. I think, yeah.
Okay.
Wow.
I think it's just very reactive.
But I think that now so do you hear us now, Gideon?
Yeah, I hear you. I just noticed that moving it around didn't make any difference. Oh yeah, that's great.
Always talk like that from now on. I like it.
Okay, so.
But if you heard that, it must have been through the microphone because there was no way the computer was going to pick that one up.
All right, cool.
Yeah.
I have
So
the
it's
mic in my ears the whole time, so I thought I'm picking
All
up.
right, okay.
Doesn't mean it's going to the
Yeah,
computer.
I know.
Anyway, let's just keep us like
Yeah.
abreast of the sound issues so we can tweak them, and maybe next time we'll get a more omnidirectional.
It's definitely a lot better now, actually, Adrian. I can actually hear you.
Okay,
So
well, now we actually
maybe
get the microphone, so maybe that's why.
So Josh, you asked about specialization. So
Yeah.
is there?
Yeah. So specifically, do we need to worry about the interaction of so the union types and the intersection types with specialization? Do we have to worry about that? Because if we're going to say specialization is not going to be included in Scala 3, I just want to make sure that we're all clear on that, or have made a decision before we decide, because that would really complicate everything, and I don't think we want to deal with that.
If specialization is in, regardless of whether it's going to be in or not, it won't interact with union and intersection any more than any of the other type system features we have. If your type parameter becomes int at call site and not any other thing than int, just so int or string doesn't qualify. If it's int, it gets specialized. If it's int or string, it doesn't get specialized the same way that if it's any val, it wouldn't get specialized.
But it introduces more, it's not really related to specialization, but it introduces more opportunities for confusion around boxing. Like if you have string or int, you get the same result as string or integer in terms of boxing.
Yes. Yeah, you do. Yeah, right. Sure.
And people might naively expect that string or int doesn't box on the inside.
Right.
Yeah. So like, especially for people writing performance critical code, you have to be very explicit, and for each of the target platforms. Like, I think we need to be careful for those kind of features. I do think like union types, I would love to make use of in performance critical code, but like you need to be very clear where you get the advantage and where you don't.
So in a sense, the thing is really clear if you put it the right way, which is that a union type will always remove one level of boxing compared to an either or an option, right? Right now, if you put an int in the left of an either, you get two boxes. You get the integer box and the left box.
Yeah, you also need to know how it disambiguates between the two types at runtime when it's ambiguous to the call site, right? Like all of that. Anyway, those are the questions I have, is like diving into that a bit.
Yeah, so that's a totally different question, which is about the semantics of the thing and what to do with it and what not to do with it. And definitely don't use union types instead of either. Like, those are two different things. If your codes previously used either, use either. And because that's the correct type parametric thing, which is easy to reason about. It's the good default for 99.9% of the cases. If you're writing performance critical codes, then evaluate things differently. But then if you're writing performance critical codes, you should learn about these things anyway, right? You should know what you're doing. I mean, I don't believe anyone can write performance critical code in Scala right now without knowing exactly what boxes when. So you would have to learn that, yes, union will box primitives and not anything else. And that's it, right? That's
okay. Should we look at the clock?
Yeah, because we have 10 minutes until we end this meeting. So, I mean, we don't have to discuss everything today. I mean, these are like lengthy discussions, so it's good that we just discuss here and there different things, and then we move on. So, yeah.
Okay, next thing is implicit function types. So that's a very high-profile feature. There has been a Popper paper and Popper talk earlier this year. So implicit function types are, in a sense, a logical complement to what we have. So essentially, we just say, well, hey, methods can have implicit parameters. So why shouldn't functions have implicit parameters? So essentially, first-level functions. It turns out that once you do that, you get a lot of new expressive power. So The one thing I'm personally looking forward is that the new Scala compiler has essentially implicit parameters everywhere. So essentially everything is parameterized by an implicit context. With implicit function types, I can get rid of that because I can just make essentially a type alias for the return type, CTX of whatever the original return type was, and that will inject the parameter. So no more C of implicits. It can also do things like the reader monad, only much more efficient. So we have a test that shows that it's about roughly 10 times faster than if you do it with the typical monad way in the reader monad. It can do lots of interesting things, and I think all that has to do with the fact that it's sort of the canonical way to do scope injection. So if you want to essentially have something that essentially where the context tells you, hey, this thing now should be available in the scope as something you can reference without Lambda abstracting it explicitly, then you can get there with implicit function types, and that gives you a lot of expressive power. So that was feature number 3. Any questions on that?
Well, I would like to challenge the canonical aspect about the scope injection. It's definitely the canonical way of implicit scope injection. It's not necessarily the canonical way of doing normal scope injection.
Are we talking about dynamic or static scope injection?
Static.
Static.
Because the thing is that the implementation of normal scope injection that relies on implicit function types actually pollutes your normal scope everywhere, anyway. It's just that it restricts the usage at some points. But if you have several scopes that want to use the same identifiers in different scopes, you can't do that with the normal scope injection implemented on top of implicit function types. So canonical, I would be I would be not as absolute.
Yeah. You could I guess I was referring to canonical because there's an argument I think was made in the original paper on implicit parameters by who was that? John Launchbury, Eric Meyer, and third one, who said, well, essentially implicit parameters are the canonical thing of comonadic abstractions. And for me, comonadic abstractions are sort of the classical thing of scope injection in a sense. You manipulate your environment, you inject things in the environment. But I was arguing more from a typing rules level and less from a lexical level that I said, yes, I mean, if you have a name clash here, then we have a problem, yeah. But anyway, that sort of was a more philosophical thing anyway. Good. Any other comments on implicit function types? Okay, then I go on to dependent function types. That's the last new type thing. So initially, sort of the initial motivation is sort of like implicit function types to say, hey, we have dependent methods. Shouldn't we have dependent functions? And that's what dependent function types give you. I would say it's an obvious win if we have that. It gives us essentially ability to abstract over this idea of implicit methods in the functions. And well, I guess the more we can do, the better. Initially, I was scared of that because I said, well, hey, we have this new class of functions, and they sort of violate this principle that in the end, in Scala, everything is an instance of a class in some way. And it turned out that actually we found a really nifty way to model implicit function types as essentially plain function types with refinements, so that we didn't have to abandon any of these principles. So I think that once that way was found, I think it's a nice way to essentially extend the language with them. The
last frontier is polymorphic function types.
Yes, and we are looking into that, but maybe not for 3. So it's not. Okay. So, yeah.
Got to leave something for that.
Okay, but let's talk with Guillaume. Yeah. He wants polymorphic, and I think several other people would like as well. Yeah.
Great.
And the last one is trait parameters. So I just have to see what we have there. I think that was under other new features. Yeah, okay. So I think you probably all know what trait parameters are. So you can pass value parameters to a trait, like you can pass them to a class. And the idea is that these trait parameters, they subsume essentially 99% of use cases for early initializers, I would say. Well, maybe not. A large number of use cases. Let's put it that way. The original difficulty to add them, so you could ask, well, why were they not in Scala 2? Originally, it wasn't quite clear what the rules are, because traits can be inherited by several different means. They form a graph. So the question is, who gets to pass the parameters to a trait? And the design here has a very simple answer, and that is essentially the first class extending a trait has to pass the parameters to the trait, and nobody else, not another trait, not a subclass. The first class extending a trait. That is gives you a slight restriction, because it means that the first class extending a trait has to extend the trait directly. It can't do so indirectly, because indirectly it can't pass any parameters. So you have to factor things. Let's say you have trait A is extended by trait B, is extended by class C, and A takes parameters. Then you can't do that, because C can't pass the parameters to A directly. So you have to write not just C extends B, but you have to write C extends A, pass the parameters with B. But I mean, we have these transformations, and they are, they preserve linearization order. So we know how to do them already. So in that sense, it's a surprisingly simple way to do trait parameters that I think does the trick in terms of expressiveness. And the motivation is first regularize the language, and B, get rid of early initializers, which are much harder to, I think, understand for people how to use and how to use correctly. There were much more. I mean, before we had this exotic feature, which was early initializers. Now trait parameters, you could say, well, it's not even a feature, strictly speaking. It's just sort of dropping a restriction that you can't pass a value parameter to a trait, but only to a class.
Just for clarification, you meant first class or object, right? That extends the trait.
First class or object, yeah.
So does that mean that a trait B that extends A cannot pass parameter to A?
Yeah. If you want to allow that, then I refer you to Donna Malayieri's thesis, but it really is a complete PhD thesis that looks at all.
I think I anticipate many problems that can come from that. I'm just pointing it out because it was made explicit.
Okay, yeah, so to tie this back into the early initializer discussion, I think the consensus there, with a 99% level of approximation, was in favor of standardizing on trait parameters and getting rid of early initializers. I think this is one of the few on the chopping block that I think is clearly, ready to go.
The only question I have is when we used to rely on early initializers, like the old designs that I remember that relied on this for lots and lots of trait linearization, ran into the lazy val hell, where everything was a lazy val to fix the early initializer problem. I think it'd be interesting to take a few of those, if we can find any still existing libraries that use this. I know of one internally that I can take a look at and try it out with the new method and see if it actually cleans it up. The nuance of having to pass it at one particular class, I'm a little curious what that does to some of these designs, because I just want to make sure that that is 99% of the cases covered and not,
It would be good to check that, I agree.
Yeah, I know the old build tool use case that wasn't the case, but that is a very odd one that I don't think we really want people to be doing. Anyway, And with that, I got to go. Thanks, guys.
All right.
Okay.
Have a good one. Thank you, Josh.
Here.
So it looks like we are approaching the end of the meeting. So any comments before we go would be welcome. So we have discussed mostly all the new batch, but we are going to put this batch now in the Scala contributor so that the community can give us feedback on all of these different features, and then we will gather the feedback, and then we will discuss what feedback we've got essentially in the next meeting, and we will do the same procedure we've done in our past meeting. So that's the idea, and yeah,
Good.
I don't think there is anything else to discuss.
No, I think we're good.
Okay, good.
Then,
Also,
thank
thank you very much for joining us. And I guess that we'll see each other on October again, and then we will have like a. Can I make this public or?
It is.
It is public,
It
right?
is public.
Okay, so then in November we will have like a 3-day. It is, right?
Extensive.
Luxurious retreat.
Yes, we will have a retreat of the SIP committee here in Lausanne, in Switzerland.
It will go down in history.
Yes.
When they met on the top of the mountain.
We will take pictures and just post them out there so that people can see us working hard. So the purpose of the 3 days kind of like meeting, if we can call it so, is to discuss the migration of Scala 2 and Scala 3 and have more a synchronized discussion between the different parts we need to discuss, because there's lots of things we need to discuss, and most of them are about like discussing internal details, implementation details, and sharing concerns and sharing other things as well. So essentially we will have this discussion in November. I think it's in the beginning of November.
First, second, and third.
Right, and then we will make sure that we have some kind of reports on the things we've discussed, so that the community can be up to date to our discussions. And then we will have, I guess, another SIP meeting in December. Is that correct? It should be. Yeah.
Christmas is canceled.
If we are not, if we are not tired of each other, we will. So we'll keep you posted on that. Oh.
Speak for yourself.
Right. So thank you very much for joining us, guys. Have a good day.
Thank you.
Thank you.
Have a good day or night.
Thank you. Bye bye.
Goodbye, everyone.
Ciao.